Hey guys, um, so I read the comments from the last video, and thank you for all your support. I think it was Patrick who said thank you, who said he was giving me support. So thank you for that, and all you other people who did it without commenting. It doesn't matter if you comment or not. Serena, I took your suggestion. I think it was Serena, right? I think so. I took your suggestion into consideration, but I don't have anything to hold my phone with. So, yeah. And, yeah, please give support. It would be nice if more people knew about this channel and subscribed to it and all that stuff. So, share it around. Trying to get it to the rest of the people in this video calls class. You know. Yeah. Alright. So, this is This Week in a Nutshell. 3/7 is 3/6 to 3/7. Yeah. Okay, so March 4th and 5th. March 4th was a review for the test. The next day was a test. It wasn't hard if you know your stuff. But we're learning about circles now. Alright, so Wednesday was mostly definitions. So yeah, let's do that. Okay. Alright. So Wednesday. I'm gonna use the type on the regular because I don't have any, because my pencil ran out of lead. This is pathetic. Alright, there we go. So Wednesday. A circle. Copy this down in your notebook because, if you don't already have it, is a set of all points in a plane at a given distance. It's from a given point in the plane. Alright, so let's draw a diagram, right? The circle, this is the center. All of these are the same distance all the way around. Alright? Same distance. And this is all set of points. Alright. Next definition, a chord of a circle is a segment with both endpoints on the circle. Alright. So, say we have the circle, right? It's just this. That wasn't drawn very well, but you get my point. That's the chord. So now the diameter. There's a lot of definitions, so it's going to take some time. Diameter is a chord. It's a chord that passes through the center of the circle. All these are in your springboard, page 9 and page 334, I think. So let's draw a diagram of this. So this is a circle. This is the center, and you see two endpoints on the circle. It's a chord, and now it's also a diameter because it passes through there. Now, A radius is a segment with one endpoint on the circle and one endpoint at the center of the circle, or the length of the segment or basically it's not just full segment. Basically the radii is also the length of the radii, if you get what I mean. Like, so hold on, let me finish out this definition. From the center to any point on the circle. Okay, so if that's center, this is a point on the circle. Draw a line. This is the radius, and this is called the center A, and this endpoint B. So you can call this segment the radius, but you can also call its distance, its length, the radius too. And then the plural of radius is radii, if you didn't know that. And then tangent. A tangent line is a line in the plane of a circle that intersects the circle. Intersects the circle in exactly one point. Or it's a line that intersects a sphere in exactly one point, but that doesn't matter right now. So there are all the definitions so far. There's still more. Just take some time to copy this down if you don't have it in your notebook already. So let's draw a tangent line, right? So here's a point on this tangent line. Just go straight through there. Not intersect any other point. This is called the point of tangency. So that's a tangent. It's called a tangent line, but it also can be called a tangent. So yeah, only 1 point. Exactly 1 point. And then lastly is concentric circles. Rules are circles with the same center. Like that. Okay, so let me. So say this is circle, right? That's the center, which is also could be another. But this circle also has the same center. Looks like an eyeball. All right. And then an arc. That's the last definition. Is a part of a circle consisting of 2 points on the circle and the unbroken part of the circle between 2 points. Hit copy down those definitions now. Alright. So it's like this is the circle. And this part could be an arc, you know? Okay. So right now, I want you to draw a circle. Draw a point of concurrency. Not a point of concurrency, the center circle. Center of the circle. Now I want you to draw a point on that circle. Now have a radius. This is also on page 335 if you need it. Number 3A. Alright. It's gonna be hard because I have to hold this and also hold this ruler at the same time. Alright. Boosh. There's a radius. Now, draw a tangent line through this point. This is extremely hard. Yeah, I see why I need a stand for this, Serena, but I don't know how. I don't have the money to get one. So, what do you notice about this? It's 3B. They look perpendicular, and that's because they are. So that's cool. Okay. Let me show you how to find the point, the center of a circle, using constructions and all that. Alright. So, let's draw a circle. This doesn't work as well as you draw your own circle. Anyways. This is going horribly. I'm sorry. This is harder. Alright. That's pretty much a circle. So, what you want to do is find 2 arcs. See, there's an arc. I don't have other colors right now, so that sucks. There's an arc. This is not going to be perfect because look at the circles. Horrible and lumpy. Now, you want to find the perpendicular bisectors of both. Now, draw a chord. Actually, yeah, draw a chord between both of these arcs. This will help you on what's it? On page 336. On page 336, there's 5 through 5. No, it's not, there's 6 and 7. But they had to deal with this wheel, like this one, you see, right here. And you'll do it like that. That's what the end product will look like. Like doing this can help you find the diameter of the circle. Hold up. Alright. This is gonna suck. The reason you're seeing black is because I put the phone down to put in my compass. Pencil back in compass. Right. This is really hard. So sorry. Really hard to do. Alright, so I should do like that. You do the same thing for the other side, and where they intersect, I'm not going to do the rest of it because it's too hard. With trying to film this at the same time while doing this. Just where they intersect, say there, would be the center of the circle, and then you just draw a chord through it to find the diameter, which will help you on this problem. Alright. One more important thing. Take this out again. I crumpled the other paper on accident, stupidly. So, since like the radius and the tangent make that right, also create right triangles, which will help on like. So we also did like 8, 9, and 8, 9, 10, 11, 8. Not 8, 9, 10, 11. So we did 7 through 12 on page 336 and 337. So if you haven't done that, please, it's good practice. Alright. Now we're going to start Thursdays. We have 3 theorems. I'm going to prove the first one. Alright. Let's draw a circle. We'll put the phone up for a second. It's a horrible video, I'm sorry about this. Okay, so draw a circle. Point of concurrency is right there, right? And not the point of concurrency, the center's right there. And then draw the diameter. Hold on, let me put this down again, I'm sorry. That's the diameter, pretty much. Now draw a chord that's not the diameter. I didn't do that very well. Now draw a chord. No, I'm sorry. I'll draw a chord that's not that diameter. Draw a chord perpendicular to the diameter. I'm gonna just use my protractor because it's gonna take some time figuring out all this stuff. With a compass. Okay, look. So I would use a compass to be better, but yeah, this is a chord and it's perpendicular, right? An important thing is that it should have 2 points at the center, and just thing to remember: if you have 2 points, the center and a random point, always try and draw a radius. Let me sketch this out for now because I spent too much time doing all this stuff. Look, it creates 2 right triangles, right? So obviously this is congruent, right? And since radii are congruent, right? Radii are just congruent because that's the thing. You just remember that radii are congruent. So by HL, these 2 triangles are congruent, and by corresponding parts are congruent. Corresponding parts of congruent triangles are congruent. These are congruent. But then another way you can find this out through the Pythagorean Theorem is, like, say, these are both c squared, right? And then they'll be like a squared, b squared, right? And they're the same, since these are the same. This is say is b and this is x. B So, and then it's x. Yeah, just skipping over all the math right now. And you set them equal to each other because they can, transitive property, right? And then you just square root both sides, b equals x. So these are congruent by that. And by doing this, you just proved the diameter bisector theorem. Wow. So it is if a diameter, this is going to be pretty wordy, so, is perpendicular to a chord, then, actually no, not this one. This one's not going to be wordy. This one's fine. Then the diameter bisects the chord. This is not wordy at all. Alright. So, page 340. We have this circle. I should make that bigger, but center R and two chords. And this is DC and this is AB. Now these are congruent, you see? And then say this part is X and this is Y. And these are perpendicular. You can draw radii because you always can. Because through any 2 points is a line. Always draw radii. Yeah. These would be these would be the chords are equidistant. I'm sorry, it took me a while to find the words. And then that's the homework for today, actually. Page 340 to 341, 2 and 3. That's the homework. Wow, right? Alright. So let's write this, and it's gonna be the equidistant. You guys know what equidistant is, right? It's on page 340 if you don't know. So in a circle, two congruent chords are equidistant. Wow. I said wow because this video is already 23 minutes long, 24 now, and it's only 2 days. It's a big old oof. So copy that down. It's in your book too, page 340. Okay, now one last theorem. Alright. Oh, 3 and 4 on page 342 if you haven't done that. No, 3 and 4, 4 and 5. Yep. And 7 and 8. 6 and 7. 6 and 7. There we go. Here we have one last theorem that you can prove on page 9, but we didn't do that in class, so that doesn't matter. Chord product theorem. Now this is a bit wordy. Alright, if two chords intersect inside a circle, then the products of the lengths of the segments of the chords are equal. Now, no, that's not equal. Equal. There we go. Alright, so copy that down. So let me show you what I mean. This is a circle, right? This is chord A, B, chord C, D, and they intersect at E. Alright, so it would be AE times EB equals CE times ED. It would be like that, and then you just solve with lengths and things. Alright, so I'm just going to leave you with a couple practice problems. So, first is going to be identifying things. This is one. What's that? It's a chord. Okay, cool. What's that? That's the center. Wow, you did it. Now what's this now? Give you. Its diameter. Wow. Okay, I'm going really fast. Should I go really fast? Don't know. Alright. Now, what's this? That's a radius. Yay. Now what's... Oh, that didn't go very well. This. It's a tangent line. Yay, you know. Alright. Now we're going to test out each of these theorems, because why not, you know? Actually, no. I don't have any practice problems for the theorems, because honestly they'll take a long time. This video is already 30 minutes. So there's practice on page 342, 3 and 4, and then homework for today, for Wednesday, will help you prove 340 to 341. That will help you prove the equidistant chord theorem. And number 10 on page 343 should help, and 12 and 17. Yeah, that's what we did in class. Alright, so this is me signing off. I'm sorry this video is so long. I don't even know how it got this long. So need two things of you. Two. First, please share this around to everybody who has Fuji for Geo, cause you know it mean a lot. And then second, I need a new name for this. I don't like this Past Week in a Nutshell. If you like it, comment down below. If you don't, give me a better one, please. Alright, probably be a new video tomorrow. So, see you then.